Dear students, welcome back to our channel. Today we'll discuss some problems in Riemann integration. Before going to problems, first I would like to explain step x. Definition of step x. Step x, also called integral part of x. It is denoted by like this. Its definition is it is the greatest integer. Step x is the greatest integer not exceeding x. It should not exceed x. We'll see some examples. Step of 1.7, it is equal to 1. Step of 1.5, 1. Step of 2.3, 2. Step of 3.5, 3. How it is possible? We are taking only the integral part. Suppose 1.7, we write it as 1 plus 0.7. It is the integral part of 1.7. 1 is the integral part of 1.7 and 0.7 is the fractional part of 1.7. That is why here step x is also called as integral part of x. In this real number 1.5 we write it as 1 plus 0.5. So integral part is 1, no? So integral part of 1.5 is 1. Step of 2.3, 2. 2.3 we write it as 2 plus 0.3. Integral part of 2.3 is 2. So like that we can discuss. There is one more important point is there. This is 0, 1, 2, 3 up to infinity. Minus 1. Minus 2, minus 3. This is the real number line. First of all, we will see 1.7. Here 1.7 is there. So these are all integers 2, 3, 4, 5 and so on up to infinity. These are all the integers which are exceeding 1.7. These are all integers which are not exceeding 1.7. So what we have discussed in the definition, step x is the greatest integer not exceeding x. These are all the integers which are not exceeding 1.7. These are all the integers 2, 3, 4. All these are exceeding 1.7. So we neglect all those values. Now we'll see what are the values which are not exceeding 1.7. Minus 3, minus 2, minus 1, 0, 1. All these are not exceeding 1.7. Out of all these integers, 1 is the greatest integer. 1 is the greatest integer. That is why step of 1.7 is 1. According to the definition, it is the greatest integer not exceeding 1.7. 1 is the greatest integer. Among all these values, 1 is the greatest, which is not exceeding 1.7. That is why step of 1.7 is 1. Suppose we take one more example. Again, I am drawing a real number line. This is minus 3 and so on up to minus infinity. Now we'll see step of 3.5. 3.5 here. 4, 5, all these integers which are exceeding 3.5. These are all not exceeding 3.5. Out of all these integers, 3 is the greatest. So that is why step of 3.5 is 3. This is the greatest integer among all these integers which are not exceeding 3.5. These are all not exceeding 3.5. So among all these integers, 3 is the greatest integer. That is why step of 3.5 is 3. Like this, in the same way we can see negative real numbers also. Minus 2.5. Step of minus 2.5 is minus 3. How we'll see? 0, 1, 2, 3 and so on up to infinity. This is minus 1, minus 2, minus 3, minus 4. Here minus 2.5 position is minus 2.5. Here the position of minus 2.5. All these integers are exceeding minus 2.5. So we neglect, we ignore those values. These are all the integers which are not exceeding minus 2.5. Among all these, Among all these integers, minus 3 is the greatest integer. So that is why step of minus 2.5 is minus 3. These are all the integers which are not exceeding minus 2.5. Among all these values, minus 3 is the greatest. So that is why step of minus 2.5 is minus 3. So in the similar way, we can see some more examples. Step of minus 1.7, minus 2. Step of minus 4.8, minus 5. So this is the definition of step x. Now we'll see some problems. First problem is integral 0 to 3 step x dx. There are 4 options: A 0, B 1, C 2, D 3. We'll see which one is correct. Now we'll take integral 0 to 3 step x dx. We write this integral as integral 0 to 1 step x dx plus integral 1 to 2 step x dx plus integral 2 to 3 step x dx. So 0 to 3 we have taken as 0 to 1 plus 1 to 2 plus 2 to 3. Okay. Step x is equal to 0 when x lies in between 0 and 1. Step x is equal to 1 if x lies in between 1 and 2. And step x is equal to 2 if x lies in between 2 and 3. So basing on this definition, just now we have discussed what is step x. Step of 1.5 means step 1. Step of 2.3 is 2. Step of 0.7, 0. Some examples we have seen in the definition. So step x is equal to 0 when x lies in between 0 and 1. When x is lying in between 0 and 1, step x is 0. So integral 0 to 1, this is 0. When the value of x lies in between 1 and 2, when x lies between 1 and 2, step x we write it as 1. When x lies in between 2 and 3, step x is 2. Now integrate. Integral of definite integral of 0 is 0. Integral of 1 is x. Limits are there 1 to 2. Integral of 2 is 2x. Now by using fundamental theorem, upper limit minus lower limit. In place of x, first we write down upper limit minus lower limit. Upper limit 2 into 3 minus lower limit 2 into 2. So we got 2 minus 1, 1 plus 6 minus 4. 1 plus 2, 3. So the answer of this question is 3. So D is the correct option. Second question is integral 0 to 3 x into step x dx. There are 4 options, multiple choice question. This is also A 6 1 by 2, B 9 1 by 2, C 5 1 by 2, D 3 1 by 2. Now we'll see. Integral 0 to 3 x into step x dx. In the same way we write integral 0 to 1 x into step x plus integral 1 to 2 x into step x plus integral 2 to 3 x into step x. We all know step x is equal to 0 when x lies in between 0 and 1. When x is running from 0 to 1, step x is 0. When x is lies in between 1 and 2, step x is equal to 1. Now we write this step x 1. When x lies in between 2 to 3, step x is equal to 2. So this is equal to 2 now. X into 2. Integral 0 to 1 x into 0 is 0. Plus integral 1 to 2 x into 1 x. Plus integral 2 to 3 2 into x 2x. Definite integral of 0 is 0. Integral of x square by 2, limits 1 to 2. Integral of 2x is x square, limits 2 to 3. Now by using fundamental theorem, upper limit minus lower limit In place of x, first we write upper limit, next x, in place of x we write lower limit. Same. 3 square minus 2 square. 4 by 2, 2 minus 1 by 2. 9 minus 4. 2 minus 1 by 2 is 3 by 2 plus 9 minus 4, 5. Now taking LCM, 3 plus 10, that is equal to 13 by 2. We write it as 6 1 by 2, mixed fraction. So answer A, option A is correct. Integral 0 to 3 x into step x dx is 6 1 by 2. Question is integral 0 to 2 x minus step x whole dx. Here also options are there, A0, B1, C2 and D3. Integral 0 to 2 x minus step x. We write it as integral 0 to 2 x dx minus integral 0 to 2 step x dx. Integral 0 to 2 x dx minus, we write it as integral 0 to 1 step x dx plus integral 1 to 2 step x dx. As we have discussed, step x is equal to 0 if 0 less than or equal to x less than 1. Step x is equal to 1 if x lies in between 1 and 2. Now integral 0 to 2 x dx minus of integral 0 to 1, when x is lying in between 0 and 1, step x is 0. When x lies in between 1 and 2, step x is equal to 1. X lies in between 1 and 2, step x is equal to 1. So we write this as 1. And this is 0. Integral 0 to 2 x dx minus of, definite integral of 0 is 0, integral 1 to 2 1 dx. So now we integrate. Integral x square by 2 plus, minus into plus minus, integral 1 is x, upper limit minus lower limit, 2 square by 2 minus 0 square by 2, upper limit 2, lower limit 1, using fundamental theorem, upper limit minus lower limit. 4 by 2, 2 minus 0, 2 minus 1, 1, again 2 minus 1, 1. So answer is 1. Therefore correct option is B. These are all the questions, very important questions. These questions were asked in degree college lecturers screening test conducted by the Public Service Commission of Andhra Pradesh in 2017. Hope you understood these all these problems. Thank you.